So welcome to day one of the class on Concurrent Object-Oriented Programming with Java and Android. The first half hour or so, we're going to focus on me explaining what this class is about, so you'll be in a good position to hit the ground running with the assignments that we're going to start off with. This particular slide deck is going to give you an overview of the course topics we'll be covering, the philosophy of the course, how to set up the Android Studio environment with the various tools and parts of the Android programming platform. And then we'll also talk a little bit about some of the assignments and ways to succeed in the course. So starting out with some motivation, there's a growing need, and this need has been growing for a long time, for software developers who understand how to write concurrent programs on a range of computing platforms. And this includes things like mobile devices, laptops, desktops, cloud environments, and so on and so forth. Now, even though we're going to be using Android for the programming assignments in the course, the topics we'll be covering are relevant to any platform you can imagine. So if you do web apps, if you do computer games, if you do machine learning, deep learning, and you have a need to write programs that take advantage of multiple cores, then the topics we'll be covering are relevant, even though we use Android. And the reason we use Android is just it's a cool platform to do both graphical user interfaces as well as be able to do concurrent programming, especially with modern multi-core devices where you actually have 4 cores or more on your mobile phone, which is pretty cool. So what is driving this demand for software developers who understand concurrency? Well, this demand is driven largely by advances in software and hardware infrastructure. In particular, the growth of multi-core and many-core processors. There's other dimensions here too, like high-speed networks and mass storage and commodity hardware and software platforms. But really, it's an interesting twist of Moore's law. So if you weren't aware, Moore's law is something that's been around for over 50 years at this point. And basically, in a nutshell, it says that every 18 to 24 months, the number of transistors available on a chip will double. And that's been going on for a long time. Now, it used to mean something else up until the early to mid 2000s. It also meant that the processor speeds increased every 18 to 24 months. But since about the early 2000s, that hasn't been increasing the way it used to. It's gone up a little tiny bit, but by and large, the processor cores are running about the same that they've ran back in 2005 or so, but there's still more and more transistors on a chip. So one of the things that's happened, is shown in this diagram here, is that people are using all those transistors to have more cores on a chip. So rather than making things run faster just by doubling the clock speed every so often, now what's happening is we're increasing the number of cores on the chip. And that, of course, has wild implications as far as how we're going to actually do the programming of our software. Back in the day, you could go on vacation and come back in 18 to 24 months and all your computer code would run twice as fast just because the clock frequency had gone up in that time. Nowadays, you have to actually think about how to program your software more effectively to take advantage of the increase in the number of cores. And there's a nice article that you can find at the bottom of this page that talks about no more free lunch, and basically meaning that we have to learn to program concurrent programs and write software that will take advantage of all these cores. So we'll talk more in just a minute about the definition of concurrency. But before I give you the formal definition of concurrency, let me just point out how it's commonly used, especially in platforms like Android. And it's often used to offload work from the user interface thread, of which there is typically one, especially in a mobile device or a user interface environment, to background threads. And so in our case, again, we're talking about mobile devices, but the concept generalizes to desktops and laptops and any kind of front-end style mechanism that interacts with the users. And so what happens here is you've got this one thread that's the special thread that interacts with the user and the user interface. And then if you want to do other longer running computations that may need to block or could take a long time to run, we can have those computations run in one or more background threads. And we'll see when we talk a bit more about how things work in Android, that's exactly the model. You have a user interface thread, and then you can have background threads that do other stuff. That's not just an Android-centric thing. It's very common in many user interface platforms. We'll talk more about concurrency in more detail in just a sec, but first, let me just kind of give you some motivation for what we're going to cover in this course. So having taught these topics now for decades, it's been my experience that effective techniques and effective practices for designing and programming concurrent apps and concurrent mobile apps and so on are not best learned through generalities and platitudes. There obviously are some great concepts, which we will cover. There's some great theories, some of which we'll talk about. But in my experience, the way to learn this stuff is to go deeper than just the concepts. And sitting and thinking is not sufficient. You actually have to do. So instead, my experience and the way I teach my class is by using lots of examples to show how to develop concurrent programs and to show how we can make them easier to read and write, show how to make them easier to maintain and modify, show how to make them more resilient, more efficient, and so on, by applying time-proven software patterns and object-oriented, and to some extent, some functional design and programming techniques. So this class is going to involve lots and lots of hands-on software development and also getting accustomed to running unit tests that will hopefully detect many of the problems in your code before you run into them through other ways, or more specifically, before I run into them when I grade them or when the TAs and I grade them. So this, as I mentioned before, this is largely a course on object-oriented programming, though if you also know things like functional programming, if you've taken my other course on functional programming, or if you just happen to know some of the modern Java features, you can also use those features throughout the course as well. So let's talk a bit about what we'll cover in the course. So as you might expect, based on what I've said so far, the focus is going to be on foundational Java concurrency mechanisms, and to some extent, some Android concurrency mechanisms as well, although we're not going to focus nearly as much on them as we will on Java for obvious reasons. I'm trying to teach you things that'll be useful beyond the Android platform. We'll be focusing on the features that are available in modern Java, which is Java 8 and beyond. For the purposes of Android, at the moment, we're limited to Java 8, although the forthcoming versions of Android Studio will finally allow us to be able to use features in Java up to Java 11, which is fantastic. Within this context, of course, we're going to talk about a bunch of different mechanisms. We'll also be covering patterns and frameworks, which are two of my favorite topics. I've done lots of work over the years on software patterns. I've written a bunch of books on software patterns, written lots of papers on software patterns, and I've also written books and papers on software frameworks. And so we'll spend some time talking about what a framework is, and you'll get lots of experience applying frameworks both in Java and the Java platform, as well as some frameworks in the Android platform as well. And I'll explain when we get to the later point in the course what a framework is, but you can think of a framework as loosely being an integrated set of classes and objects that collaborate to provide a reusable architecture for a family of related applications. And we'll see that Android has piles of frameworks, some concurrency frameworks and beyond. Java has piles of frameworks, concurrency frameworks and beyond. And by the time you're done with this class, you'll have a much deeper understanding of how frameworks work and how you can use them to good effect to be able to reuse your code or reuse other people's code and be able to get your applications done much more quickly than building them all from scratch. I'm assuming that you either know or can quickly learn Android, and luckily you don't have to know very much about Android in order to get the ball rolling here. Android Studio, which is just a thin wrapper around IntelliJ. The Java 8 features will focus primarily on the object-oriented aspects. Not so much Kotlin. We might talk a bit about that, but we're really going to focus more on Java. And Git, which is a version control system. If you don't know anything about these things, if you don't know anything about Java, then we have a problem. So we should talk about that. But the other topics are things that you can also learn by taking a look at a series of MOOCs I put together. And if you look at item number 12 in the frequently asked questions folder in my GitHub repository, it'll give you a lot of tips about how to do this. So let's just go over here real quick and take a look at the frequently asked questions file. This is something that's part of my website for the class in GitHub. You'll get very used to this over time. And this has got about, I think it's 18 answers to frequently asked questions that have come up over the years as I've taught this course. So there's some stuff here about what if you want to learn about the topics that you need to know about, but you're not familiar with them. So if you go here, you can learn about how to go ahead and sit in on those MOOCs. I suspect most people can probably do this stuff without having to take a look at that material. But if you want to, it's there. And so feel free to avail yourself of it if you so desire. Okay, so let's talk a bit about the material in the course. There are going to be three primary topic areas. First and foremost will be the Java and Android threading. And in this space, we're going to talk about lots of ways to run elements concurrently using Java threads, using Java runnables, using the Java executor framework. And we'll talk also a little bit about some of the Android concurrency frameworks as well, such as the async task framework and the handlers, messages, and runnables, or Hammer framework that comes with Android. So a lot of focus on that topic area. We'll also spend a lot of time, probably an equivalent amount of time, talking about Java synchronization mechanisms. And these would include things like the built-in monitor objects that come out of the box with the Java programming language, as well as a whole myriad pile of synchronizer classes that you'll find in the Java util concurrent package. And again, there's probably about a dozen of these things that we'll cover here as well. We'll talk about some concurrency and some synchronization patterns as we go through the material. That's not really the main focus of the course, but if you want to learn how to be a good concurrent developer, it pays to understand these patterns. So I'll provide you some links and some descriptions of them as the need arises. For various reasons, we're going to kind of bounce around between these topics as we go through the course. And the primary reason for this is that your programming assignments will typically require you to learn some threading mechanisms to do part A of each assignment and some synchronization mechanisms to do part B of each assignment. So we kind of do threading followed by synchronization, get the assignment done. Then we do some more threading, some more synchronization, get the next assignment done, and so on and so forth. And I'll talk in a second about how the assignments work as well. Each topic we're going to be covering, it has a whole bunch of lessons associated with it. Each lesson is composed of parts. Each part is a single lecture. And you can find screencasts of each part, in other words, the MP4 version of the lectures, as well as the PDF version of the slides that go along with the lectures, which will be uploaded to my website. And this is another thing that you'll need to learn about. This is the website we'll be using for the course. You can see here, it's available at my website at Vanderbilt. It says things like when the class is being held, which hopefully you know by now. It says when the final exam is, has some notion about the prerequisites, a whole bunch of links to things about office hours and so on, which we'll talk about in a minute. So the office hours are set up so you can learn how those work. And we are very fortunate to have a bunch of very talented TAs and graders in the class who've taken the class before, who can help you through all the things we're doing. And we have office hours every day of the week. Sometimes during the day, there's a couple in the evenings. So that should give you a chance to get your questions answered despite everybody's crazy class schedule. So I recommend you take a look at the various links here to see more about what we're talking about. The course videos and slides will be put here if you want to see what they look like. Right now, the walkthrough of assignment 1A is available. If you click on that, it'll take you to YouTube where you can watch the video. I won't watch it right now because it's distracting, but be aware that you can go and see what the first assignment's about. And the other thing to note here is that, go back, there's a couple of days throughout the semester that have been designated as so-called reading days. And that will be February 24th and April 7th. And we'll come up with creative ways to use that class time other than just me giving lectures, and we'll have a chance to kind of do some team building and discussions and look more broadly at some of the topics that we're covering. All the programming assignments, as we'll see, are available in GitHub. The one you want to start with is assignment 1A. And of course, you want to go ahead and clone this using the appropriate mechanism for cloning the repository. So just be aware of that. And I also have assignment 1B up. Don't worry about that at this point, unless you're really curious. We'll do that one after we get done with assignment 1A. So that's just a quick tour through my website. Please take a look at the website. And this is where we're going to use, this is how we're going to communicate what we're doing each week, and all the videos will go up and so on and so forth. Okay. There will be periodic tests or quizzes that will cover the material that we discuss in the lectures. All the tests, quizzes, including the final, etc., are all closed book and closed internet and closed talking to your friends. So what that basically means is that you are responsible for doing the work based on what you know when you come to the quiz, not what you can learn from other resources around you. The first test quiz will be on Wednesday, February 3rd via Brightspace. And the way that this works is I'll give you typically a 12-hour period in which you can do the quiz. The quiz will be roughly 45 minutes in length, and we'll talk more about how to study for the quiz in a second. Ideally, we'll be able to grade the quiz and get it back to you by the next class. So quizzes are always on Wednesday. And so by the next Monday, hopefully things will be graded and back, and then I'll go over the answers in class. Sometimes, especially if the TAs are super busy, we don't get it that Monday, but we should definitely get it by the next Wednesday. And that's one of the benefits of being a somewhat smaller class. We don't have 100 people in the class, so we can get turnaround pretty fast. I recommend that you study for the tests by reviewing the slides and watching the screencasts, and this is very, very important, by coming to class. One of the things you'll see we do after an assignment is due is I review everybody's code, which I'll talk about in a second. I give you feedback, and then I create something called a frequently made mistakes video, where I walk through all the mistakes people made and kind of give some tips on how to fix the problems. Those kinds of frequently made mistakes are great material for the quiz, because it's something that makes people stop and think about what they've learned. So make sure you come to class, because that's where we talk about the frequently made mistakes. Make sure you watch the frequently made mistakes video. Make sure you understand what's wrong with the material in the frequently made mistakes video, and then be aware of how to fix it. So a lot of the quiz questions come from that. If you don't attend class, you'll be penalized. So I'm pretty strict about attendance. And so make sure you come to class. And there's a whole summary of that here on my website, which we might want to take a quick look at. So basically, it talks about showing up to class, doing the work, and there's some other things we'll talk about in a second having to do with programming assignments and the submission process. So please make sure that you attend and participate. And I'll talk more about that in a second. Okay, so there may be a cumulative final, although if we have one, it'll really focus on the last couple of weeks with perhaps a few other questions from before. And that will be on May 7th from 2 to 5 p.m. if we have one. And the reason we sometimes have one and sometimes don't, it all depends on how the programming assignments go and whether people are being successful with the programming assignment. Sometimes we focus more on a programming assignment at the end as opposed to the final. But it's kind of flexible. So count on having a final, but there may or may not be one. Let's now switch our attention to talking about the assignments and the assessments for the material in this class. So all the material in the class should be written using Java, and particularly Java 8, using Android Studio. You can use any IDE you want and any version you want if you want to, but you have to make sure that your submissions work properly and pass the tests with Android Studio, which the latest version, I'll talk about that in a second, as well as Android 11, which is API level 30, also called the R version of Android. They used to name the versions of Android after pastries and desserts, and they kind of stopped that. I think they couldn't figure out what to do for Q, so they stopped giving it dessert names, or maybe they had to pay too much in royalties to whoever owns Oreo or whatever. But now they're just letters and they have API levels. So you want Android 11. Luckily, the version of Java needed to do the assignments comes pre-built with the latest versions of Android Studio. So you're set if you install that properly, and we'll talk about how to do that in a minute. With the Arctic Fox version of Android Studio, which is not really even in beta yet, it's in the Canary release, that will have support for Java 11. We may or may not get to that in this course, but just be aware for future reference that the Google folks are indeed updating Android to cover later versions of Java after about 5 or 6 years. Android Studio has all kinds of cool capabilities to build Android apps. We're going to use few or none of them because you're going to get the app pre-developed for you, and then you'll fill in the blanks with the concurrency parts. But if you want to learn more about Android and the mechanisms there, feel free to take a look at the Android Studio link and learn more about what it does. It's very cool. You'll need to install Android 11, as I mentioned before, and if you've ever seen the famous movie This Is Spinal Tap, you'll understand why the icon for Android 11 is essentially a volume control that goes to 11. And there's a funny riff that repeats throughout This Is Spinal Tap and other things that are Spinal Tap related about a guy who the guitarist, Nigel, who wants to be able to have his amp go up to 11 because it's 1 louder than 10. So that's the joke they're showing here with their icon. All the source code for the assignments can be found in my GitHub account. Make sure you go there. So just for kicks, let's click on this. So this is the GitHub repository. I just showed you that before. Make sure that you clone that. We'll talk more about how you can maneuver through it. If you go to the wiki portion of this, you'll see that there's a bunch of helpful pieces of information like when the assignments are due, the frequently asked questions file, which we already talked about, some information about how to use Git and update your assignments based on what I put in my repository. Very, very important to take a look at that. Luckily, the TAs should be able to help you because they've all got experience with this as well. There's some tips on how to install some software that you'll need. And then last but not least, we have the list of office hours. So these are the office hours by all the TAs in the class. You can see that we have 4 TA graders, and they're all great. They've done this before, very knowledgeable. And as you can see, we have every day of the week covered in one way or another. And again, we tried to spread things out a bit. You can see there's some sessions in the evening on Tuesdays and Thursdays. A lot of people tend to have very packed schedules on Tuesday and Thursday, so we kind of push things to the end of the day there. But make sure you come to office hours and make sure you find out what's going on and don't get behind. I'll talk more about that in a second too. You'll need how to learn to use GitLab. That's the implementation of Git that you'll use in order to be able to provide a repository that you'll sync up with my skeletons. And you can see, if you take a look at item number 13 in the frequently asked questions file that explains how to do this. I'll probably go over that also in class because it's really valuable to understand how this works. On occasion, you may need to update the Git repository. For example, if by some weird quirk of fate, a version of the skeletons goes out that has a bug or a defect in it, you may have to learn how to do a Git pull to get the new version. It's not hard. It's good to know. And just be prepared for that. That doesn't happen a whole heck of a lot, but it does happen from time to time. More generally, between assignments, for example, assignment 1A to assignment 1B and assignment 2A and assignment 2B and so on, we'll often add new tests and other enhancements. So you'll have to get accustomed to knowing how to use Git. The assignments that we're going to work on will give you a range of experience with Java and Android concurrent programming, focusing again on Java 8 because that's what Android supports at the moment. And so once again, make sure that you're aware of that. You'll need to implement multiple variants of a concurrent resource manager and an associated Android app. And what this does, it's actually kind of fun. It allows us to visually demonstrate having a number of beings from Middle-earth, of course, the Lord of the Rings trilogy by Tolkien, and the beings will take turns gazing into some fixed number of Palantiri. And if you don't know what Palantiri are, take a look at the link at the bottom of the slides, or even better, go watch the movies or read the book. But you'll understand once you do that what the Palantiri are and why it's cool to have things gazing into them. And of course, it's also just a really fun concurrent resource management problem dressed up with some really interesting graphics to make the whole thing interesting. We'll use this assignment in order to be able to demonstrate Java threads, Java runnables, Java executor frameworks, Java semaphores, built-in monitor objects, concurrent hash maps, many other forms of synchronizers, as well as some of the Android concurrency frameworks. Now, again, with the exception of the handful of things we'll talk about that are Android specific, everything else generalizes way beyond Android. So once you understand how these various mechanisms work for threading and synchronization and so on, you'll be well equipped to cover lots of other domains, not just limited to Android itself. The assignment assessments will be done in a very interesting way. And this is sort of a kind of a unique feature of my courses. I've been doing this now for probably 30 years, and I really love it. Students typically like it quite a bit because you get a lot of feedback on your assignments. Now, there's a cost, there's a catch that comes with this. And the catch is you have to submit your assignments on time. If you don't submit your assignments on time, you lose a lot of points. So take a look at item number 4 in the FAQ for more information about this. And there's also some information on my website about this as well. Now, here's the way this works. What you do is there'll be an initial assignment due date. For example, assignment 1A is due on February 3rd, which is next Wednesday. And you'll submit your program, and it needs to largely work. It needs to compile for sure, and it needs to be largely complete. If you just throw random code at me, I won't review it, and you won't get a grade. So you'll lose a lot of points. What you want to do is get it as far along as you can, and the first assignment is actually quite simple. And then I review it, and I give you feedback. And then you'll typically have a few days up to perhaps a week, depending on how hard the assignment is, where you need to take my feedback and the frequently made mistakes video that I'll make and go back and revise and improve your solution. And we'll talk a bit more about how that works shortly. And once you revise your solution, then you'll resubmit it. And at some point, we'll talk about that at some point, that version will be graded. So the TAs and the graders will actually review your code. There's some really cool automated regression tests that we run in order to score how well you're doing. Then we take a look at a few other factors like your commenting style and comprehensiveness and completeness. And that will give you the final grade for that assignment. So there's multiple chances to do it right. Most people end up doing very well on the assignments unless they just completely flake out and don't submit the assignments or don't submit them on time. So in general, people do well on the assignments if they're willing to keep up and follow directions. If you don't attend class, if you don't show up, then you're going to lose points. So we'll talk about attendance in more detail, but it's really important to keep up. In my experience, almost guaranteed that people who do not show up for class, people who do not keep up, do poorly, and everybody who does show up to class and keeps up does well. So it's almost entirely bimodal in this class. So please don't fall behind. It should go without saying, but I'll mention it anyway because this has been a problem in the past, especially now that we're doing a lot of online learning. The work that you do has to be your own. This is an individual course. It follows the Vanderbilt honor code. You can read the honor code at the bottom. I think most people should know what that is by now. This applies to the quizzes. It applies to the final exam. It applies to the programming assignments. Anything that gets a grade needs to be done by yourself, not as part of a team. There are other courses in the CS program that have team-based assignments, but this is not one of them. The bulk of your grade will be based on the results of some very sophisticated unit tests. So make sure that you learn how to run them. If you watch the video that I put out for assignment 1A, I show you how to run the tests. All the videos will show you how to do that. And there's also a really cool auto grader that will tell you exactly what your score is at any given point in time. So that'll give you a lot of feedback on how to make sure that you make it work well. It's also important to remember that over time, we will improve the unit tests. So as I review the assignments that are submitted initially, I find frequently made mistakes, and then the course staff goes back and improves the unit test to try to automatically catch those problems because people often come up with very creative ways to get things wrong. And so the goal is to try to catch as many of those things through testing. And so don't be surprised if later assignments have new tests that may discover bugs that missed my review because humans are fallible and don't always catch everything. But the tests are sort of infallible usually. And so over time, we will keep improving the tests. So you have to be responsible for making sure that your older versions of the assignments continue to work as we add new tests. And that's just a good reflection on real-world software development techniques. To learn more about that, take a look at item 16 in the frequently asked questions file to see what I'm up to here and why it's important to do this. Another thing, really important, the assignment has been, the projects that we give make certain assumptions about the Gradle plugin to be used and the version of Gradle to use. Please don't change those versions. There are bugs with the most recent versions of Android Studio that make our grader not work properly. We're in the process of working with Google to get those bugs fixed, but until they're fixed, please stick with the versions that come out of the box. Take a look at item number 17 at the FAQ for more about this. The way this will manifest itself is that Android Studio will prompt you somewhat neurotically pretty much every time you start your project and say, would you like to upgrade to the new version of Gradle? And just say no every single time. It's tempting to say yes because it feels like you should be using the latest and greatest, but it will cause us no end of headaches when we do the auto grading. So please resist the temptation to upgrade to the newest version of Gradle. Just stick with what you have out of the box. This is a tentative breakdown of the weighting of the various parts of the course. So the quizzes will be roughly 45%. Those should be probably 6 or 7 quizzes. The programming assignments will be 40%. There'll be 4 programming assignments split up into multiple parts. If we have a final exam, it'll be 10%. And there's also a 5% participation grade. These weightings might change depending on various factors. Like if you don't have a final exam, then the quizzes will probably be 50% and the programming assignments will be 45%. Participation is important. It means several things. It means showing up to class. It means being involved in class. That means asking questions through the chat. When we get to question parts, it means participating in Piazza in the discussion forum. And also very, 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 very important, it means following directions. And we'll talk more about what that means in a second. So this will impact your grade. So make sure you show up, make sure you participate, and make sure you follow directions. Most importantly, you need to submit things on time. If you don't submit things on time, it screws everything up and it makes it much more difficult for me to do the hands-on assessment and evaluation I'm so happy about to do. So do not fall behind in this class. Every semester, there's usually a handful of people that fall behind and they usually end up doing very poorly. So please do not let that happen. Also, make sure you participate. 5% of your grade is on participation. So if you're on the borderline and you've participated, that will help you. If you're on the borderline and you have not participated, that will not help you. So I like to give people what they deserve. It's great if everybody gets an A. I'm perfectly happy with that. But you have to be part of the process. You have to be involved. And I say this every semester, and some people get it and some people don't. And then they're always disappointed at the end when they don't get the grade they think that they should get. And that's because they didn't participate. So please make sure you participate. It's a great skill to learn no matter what you do in life. Okay, a couple more things. Let's talk about how you install the software. So to use Android, you have to install the latest release of Android Studio. This right now is the version 4.2 beta 3, which you can get at the link at the bottom of the slide. It's very easy to install. There's versions that run on Windows, there's versions that run on Mac OS, and so on. So download it and install it. Then you want to launch the Android Studio SDK Manager for Software Development Kit Manager and select version R, which is Android 11, API level 30. And that should just go ahead and pull in all the various files that are related to that. It's quite simple, but you have to make sure you do it. Then also make sure you create an Android emulator. I recommend using API level 30. You can probably use earlier versions if you want, but there's no real need to do that unless you already have that installed from some other course or some other work. So I recommend getting Android 30 emulator, and you can do that by creating the emulator through the SDK, or the IDE as well. Also very important, make sure that you use the accelerator features if you have an Intel chip. If you have an Intel computer, there is a virtualization driver called HAXM, and Android now, I think, will automatically enable this if you're using Intel. Back in the day, you had to kind of do some magic to install it. But the good news is that this will make your Android emulator run basically about as fast as a native phone would run, which is fantastic. Otherwise, it's slow and painful. So make sure that you get that up and running. It should just work out of the box, but just be aware of that. A couple other things, and then we'll take a break and have the questions. I also think it's good to know where to get the source code. You can browse the source code at this link. You can download the source code for Android at this link. It's not necessary to have it, but it's kind of fun. The Java source code is also available for browsing at this link and available for downloading at that link. And you can get Java 8. You can get later versions of Java as well. At the very least, get Java 8. There's lots of cool stuff there. And we'll look at some source code throughout the class because it's really instructive for a lot of the features we'll be talking about. So to wrap up, as with almost everything in life, you get out of this course what you're willing to put into it. So there'll be consistent work. There should pretty much be something due almost every week or every other week. So there'll be a quiz or there'll be a version of the programming assignment, either the initial version or the final version that's due. Do not miss deadlines. I cannot emphasize that enough. That's the easiest way to lose points unnecessarily. It's basically like kicking the ball into your own goal, if you're familiar with soccer or football, as the rest of the world calls it. So don't score own goals. Don't do things that will lose you points for no good reason. So cannot overemphasize that enough. You have to follow the directions and don't miss deadlines. Also, please participate in discussions in class and on Piazza. So if you go over here, there's a Piazza page, and I can see I haven't, let's see if it's smart enough to know. There we go. It's going to log me in, hopefully. Yep. Now, something you'll notice, Piazza just changed their terms of service. So right now, we haven't got a license at the university level yet. We will hopefully get one of those soon. But in the meantime, you will get this little prompt asking you to make a donation. You can feel free to make a donation if you want to. You're not required to make a donation. Whether or not you make a donation, you can still use all the stuff here. So I will be posting lots of information on Piazza. Hopefully you'll be posting your questions there. Hopefully the TAs and myself and other students can help you with your questions. So please make sure you use Piazza as a way to communicate. There's a private way you can send me messages on Piazza, which is what I recommend you do if you have specific questions about your implementations and you don't want to violate the honor code by just posting it publicly. But for more general questions, please try to post publicly because more people can help you. And again, there's lots and lots of resources. So we have lots of office hours every single day of the work week. We have the Piazza online forum. There's some recommended reading if you want to learn about the topics. There's also tons of links in the slides to pointers to almost everything we're going to talk about if you need to know more. And of course, we record all the video lectures and put the slides for those things available as well. And that will all be on my website. Please resist the urge to email me directly unless you need to talk about something confidential. Obviously, if you are struggling with issues or you want to drop the class, feel free to email me. I'm not trying to not be communicative. It's just that if you post on Piazza, especially publicly, if you're having general questions, a lot more people can help you out a lot more quickly. I get a lot of email and I'm not always able to respond as quickly as I'd like. So please don't send me email unless it's strictly confidential. And in that case, you could also just send me a private message on Piazza. This helps to keep things separated out a little bit better. And then one final get off the stage slide. Obviously, there's lots of benefits that come these days from being a computer science major and a computer science professional. We, the profession of computer scientists, continue to do very well, even in this crazy pandemic-driven world. I saw an interesting meme the other day. It said, programmer before quarantine, and it showed a programmer sitting at his or her terminal. Programmer during quarantine. It showed exactly the same picture of the programmer sitting at his or her terminal. The point is that we can do things remotely that a lot of other professions have a much harder time to do. And not the least of which is we can give classes and take classes virtually, thereby keeping ourselves safer from the viruses that we might otherwise encounter. So you've made a good choice being in this field, and there's lots of opportunities, but you also have an obligation, as Spider-Man's uncle always said, with great power comes great responsibility, or with great opportunity comes great responsibility. So make sure that you really immerse yourself in the things we're going to cover. And I think we'll have a good time this semester.